a charged rod is brought near an initially neutral metal sphere without touching it. When the sphere is grounded Earth, there is an electric current for a short time from the sphere to the ground. The ground connection is then removed. What are the charge on the rod and the charge induced on the sphere when the connection is removed? This question is about a process which is called charging by induction, and let's review this process firstly. If there is a charged rod, let it be positively charged, and there is a metal sphere, it's very important, sphere must be made of metal, of the conductor, not of the insulator, because electrons can move freely through the metal. And a charged rod is brought near an initially neutral metal sphere. It doesn't touch a metal sphere, because definitely if you touch a metal sphere with a charged rod, positive charges just will be distributed over a rod and a sphere, and they both finally will be positively charged. But we can see the process so that a charged rod is brought near and it doesn't touch a metal sphere. And what happens? How to remember? And actually you remember that what opposite charges attract each other and same charges repel each other, and these positive charges like attract minuses, negative charges, and there will be such a distribution of charges so that a metal sphere will be or will have more negative charges to the left, closer to the rod, and more positive charges far from the rod, to the right. But, and actually what happens, electrons just move to the left, closer to the rod. Why? Because positive charges of the rod attract electrons, and for all such processes, just remember that only electrons are moving. We don't say that positive charges move to the right or something like that. Electrons move closer to the charged rod, but to remember, just to remember, to be easier to remember, pluses attract minuses, so minuses closer to the rod. So, and finally, or now, a metal sphere is still neutral. It's very important. There is just such distribution of charges, but number of pluses is equal to the number of minuses, so it's neutral. But then we connect this sphere to the Earth with metal. Why? It's very important, with conductor, not insulator. And the Earth is like unlimited source of electrons, so that electrons can move freely to the Earth or from the Earth, and all these minuses are like trapped, or they are attracted or are kept by these pluses. But these pluses attract minuses from the Earth, and electrons from the Earth just neutralize or cancel all these pluses, all this positive charge. And then we cut the wire, remove connection to the Earth, and what we get, that a sphere becomes negatively charged, and then all this negative charge will be just evenly distributed throughout the sphere. So if a metal charged rod is positively charged, finally metal sphere becomes negatively charged. And what about direction of the current between the sphere and the Earth. You remember that current direction of a current is what? It's in opposite to the direction of the electron. So current is to the Earth. So current to the Earth. Current. Rod. Sphere. And if a rod is negatively charged, sphere will be finally positively charged, and the current will be what? To the sphere. And to our situation, given that current is to the Earth, or electrons are moving to the sphere, so it's just this situation. So a rod is positively charged, sphere finally becomes negatively charged, and you can see that we need what are the charge of the rod and the charge induced. It means finally on the sphere when the connection is removed. So it's plus minus, rod plus minus. So it's C. And that's all for this question.